All right, so yesterday we were looking at if we were to combine absolute functions together, like subtracting them, adding them, maybe dividing them in the near future, what would their graphs look like, and how could we represent those graphs as a piecewise function? We're going to try two of them today, actually, without those guided chart notes that we did yesterday. So if you take a look on page 89, notice how it's just the problem and just the graph. Okay, we did talk about yesterday a process to kind of go through, so we're going to see how much of that we can repeat today without having those little guided notes available. Okay, so we're going to add these two absolute values together. We're going to write the piecewise function. Based off of that, we'll graph it. Where do we start? If you need a reference, go ahead and switch the page to help you out. Go ahead, Kyle.
So set each absolute value piece to 0.
Okay. So if you were to set the first absolute value, okay, x plus 2 equals 0, the x value would be -2. If you were to set the other absolute value equal to 0 and solve for x, we would get 3/2. Do we remember what those values represent, maybe in terms of the graph? What those numbers mean? Like, why on earth do we need to find those? Why are they important? Addison, yeah.
Vertical line
It begins with a V. Vertex. Vertical line. Okay, vertex. So these are the locations of where a vertex or a vertex is, like kind of a sharp point in the graph. That's where one line begins, or sorry, where one line ends and the other one begins, okay, where they're kind of meeting up. So we want to figure out those values. So now that we have those changing spots, or where those vertices are, what do we do with them? Can we reference maybe? Switch the page? Yeah.
You have to figure out the intervals on the graph on a number line.
On a number line. Okay, so typically an absolute value function, okay, if it's a V shape, has a domain of all real numbers. You can go forever to the left and forever to the right. So that's why our number line is going to go forever to the left and forever to the right, okay, using some arrows. And we're going to take those vertices or changing spots that we identified and label them on the number line. So in this case, we're creating 3 intervals. We have -infinity to -2, in between -2 and 3/2, and then 3/2 to infinity. Let's continue with this number line. What else do we have to fill in on this number line? Yeah.
You have to put each piece of the equation in
Okay.
parentheses instead of absolute value.
Perfect. So we're going to take the original equation and we're going to write it in each interval, okay, so 3 times. And instead of having absolute value bars, we're going to use parentheses. So again, I apologize if you have to write a little small to fit those in, but we'll give it our best. So the reason we write it in each interval is because we want to figure out what would this graph look like, or how would it behave on that interval. That's going to help us eventually graph it. Okay? So now that we have those equations in, there's some other piece we have to do to help us simplify them, because right now they're all the same, and if we were to simplify them, they would all result in the same equation or line, but they're not always going to be the same. What else do we have to do with those intervals, those equations? Yeah.
Don't you have to plug in both pieces into the equation for x?
Okay, so we're going to pick some numbers to plug in for x. So on this first interval, from -infinity to -2, pick any number you want. You want to do -3, -4, something like that? It doesn't matter, okay? So we're going to take whatever number you pick, and we're going to plug it into each parenthesis value individually. So let's say we pick -4. If you plugged in -4 into the first parenthesis, -4 plus 2 would be a negative value, right? I don't care about the number. I care if it's positive or negative. So in front of this parenthesis group, we'll put a negative sign. If you were to plug in -4 into the other parenthesis group, you would also get a negative value. So we're going to put a little negative in front of that parenthesis. And we're going to repeat the process, but for the other intervals. So in the middle interval, you got to pick some number between -2 and 1.5. That's the same as 3/2. What number do you want to pick? 0? Okay. 0 plus 2, that's a positive value. 2 times 0 minus 3, that's a negative value, yeah.
If you put 3/2, you get 0.
Well, we're not doing 3/2. That's a changing spot, okay? We want to figure out what's happening in between the changing spots. Okay, the last interval, something between 3/2 and infinity. Yeah. 2. All right. 2 plus 2 is positive. 2 times 2 minus 3, positive. All right. So now that we know how each parenthesis grouping is in terms of its sign, we're going to distribute in all of those signs and simplify to get our equations for the piecewise function. So working on our first interval, we're going to distribute in the negatives into those parenthesis groups. So the parentheses would go away, and we can combine some like terms. Looks like we'll get -3x plus 1. So in terms of our piecewise function, that's our first equation that we're going to write. On the next interval, if we distribute in a positive sign, that's not going to change anything. But the second group, we have to distribute in the negative. So combining like terms, looks like we have -x plus 5. There's our second equation. And for the last interval, distributing in those two positive signs isn't going to change anything. So combining like terms, we got 3x minus 1. So with this number line, let's go ahead and write our piecewise function. We have the 3 equations, so we'll just copy those down. But now we have to figure out the domains or the constraints. Where does each piece kind of show up on the graph? So where can we figure out that information from? Yeah. The number. Perfect. All right, so our first equation shows up from -infinity to the first changing spot of -2. So those are x values that are smaller than -2. Now we said -2 was a vertice. Okay, on an absolute value shape, there's a closed dot at that vertex, so you can put a bar there. The next equation based off the number line shows up in between -2 and 1.5. And again, if those are vertices, you could include the bars. And our last equation shows up from 1.5 to infinity. So those are x values bigger than 1.5. And again, if that's a vertex, or vertex, you can put a bar there. Did we remember that from yesterday? We didn't lose it, right? Good. Okay, so now that we have the piecewise function, let's go ahead and graph it. So we said our changing spots were -2 and 1.5. So that's a little different. All right, if we were to graph the first equation, we can plug in -2 to get our first point. So that would be 6 plus 1, or 7. And that's some type of vertex there, so a closed circle. How can we get another point to help us graph this line? Yeah.
Just choose another number in the first section.
Let's do that, okay? You could pick any other number you want in this first section over here. Gary, did you want to pick a particular number for us? -4? Okay, if you want to plug in -4, this would give us 12 plus 1, which is 13. So at -4, you get out 13. You could definitely connect those two dots to get your line. Some of you may have thought, well, I could use the slope, rise over run. That would give you another point. Notice how the slope is negative, and if you were to go down 3, right 1, you wouldn't be in the right region, so you'd have to go backwards. Okay, up 3, left 1, and notice how that would have worked out too. Okay, so you have options if it's a line. You can use the slope, or you can pick any other x value you want to plug in. Let's try the next one. Plug in -2. We would have 2 plus 5 is 7, so that's the vertex we already plotted. And if we were to plug in 1.5, -1.5 plus 5 is 3.5. Now we already know this equation is going to be a line, so we can simply connect the dots between those two. And for our last piece, if we plug in 1.5, 3 times 1.5 is 4.5, minus 1 is 3.5, so we're at the same spot. We need another point though. So what do you want to do? Yeah.
Can you plug in 2?
Plug in 2, plug in 5, plug in any other number you want. Okay, maybe we'll plug in 2. So that'd be 6 minus 1, which is 5. Alright, so there's your other line. You could have used the slope. Go up 3, right 1. That would have worked out too. So again, it kind of looks like a V, okay, but it's a little distorted because we're adding two V's together, but still kind of has that basic V shape to it. Now that we have the graph, let's go ahead and figure out domain and range. So drag your pencil left to right, down to up. What can we label as the domain and the range? Good, Kyle? Okay, so domain is all real numbers. If you want to put that little double-stemmed R there, that's okay. What about range, low to high? Yeah.
3.5 to positive 50.
Good, and can you tell me brackets or parentheses on any of this?
It would be brackets and then parentheses.
Right, perfect, there we go. How do we do? Pretty good? All right, we're going to step it up a bit with the next one. Okay, we're not necessarily going to graph this one because it is a little complicated. Maybe if you wanted to graph it on your own, you could give it a shot. But I'm just going to be concerned with the piecewise function for this one. Notice how this one we are dividing some absolute value. So division we really have to be careful with, because what can we not do with division? There's a restriction here. You can't divide by 0. So we have to keep that in the back of our heads as we go through this process. Okay, but let's go ahead and continue here. If we were to set just the absolute value equal to 0 and solve for x, where would our vertex slash changing point be located? Where one line ends and the other one begins? 5 minus what number would give you 0? We thinking 5? Okay. While we're at it, let's go ahead and think about this. We said we can't divide by 0, so what value can x not be? What can we not plug in there? Yeah, -3. Okay, so what's going to happen is we're going to have to use both of these numbers on our number line. Okay, so not only are we including that changing point of 5 like we typically do, but we also have to take into account a number that we cannot plug in. So let's go ahead and we'll write out our number line. We have -3 and 5. Now what I'm going to do on the -3 is I'm just going to put a little X on it, because that's going to tell me that I cannot be that value. I have no graph at that spot. Okay, but it's still going to work the same way. We're going to rewrite the original equation in each section, and instead of absolute value bars, we're going to use parentheses. So 5 minus x minus 8 all over x plus 3. Alrighty, pick any number you want between -infinity and -3. I'm going to do -4. Okay, so let's say we choose the x value of -4 for that section. If you were to plug in -4 just into the parentheses, not the entire equation, okay, just the parenthesis portion, we'd have 5 minus -4, which would change to a +4. So 5 plus 4 is a positive value. You get 9. Pick any number you want between -3 and 5. Something easy. Good, Kyle? 0. Okay, plug in 0 just into the parenthesis. 5 minus 0, still positive. And then any number you want bigger than 5. Maybe we'll do 6. Okay, just into the parenthesis section. 5 minus 6, we got negative. All right, so let's go ahead and simplify each of these sections, figure out our equations for the piecewise function. If we distribute in the positive, nothing's going to change. But we can combine some like terms up top. 5 minus 8 would give us a -3. Can we keep simplifying from there? Do you guys feel like canceling out those 3's? Do you feel like canceling out those x's? I hope not. Okay, we can't because we are adding and subtracting things. You can only cancel out items that are being multiplied. What do you want to keep doing though?
Could you calculate rate of 1 please?
Let's do that. Okay, so this is really tricky. Right now, nothing cancels because they don't exactly match each other. But do you notice how the terms up top are the exact opposites of the terms down below? So what we can do is if we were to take out a negative from the top, that would change this to an x plus 3. And we also have that same x plus 3 quantity down below, right? So now that these match exactly, the whole terms or quantities would cancel. and we're simply left with a -1. Just that negative sign's left over. So this is actually our equation for the first section, just -1. Okay, let's try the same thing for the middle section. If we distribute in the positive, didn't we already do this though? Like it's going to be the same thing, right? So we're going to end up with -1 for that guy too. And let's see, the last one, if we distribute in the negative and then combine some like terms, we have x minus 13 over x plus 3. We can't take that any further. Can't cancel out those x's. All right, so we got to put all of this together. So let's write our piecewise function. This particular function was named p of x. So we'll go ahead and write p of x equals something. I hope I have enough room here. All right. Now notice how we did have 3 sections, but we only really resulted in 2 equations, correct? Weren't the first 2 equations exactly the same? So we're just going to write -1 once, even though it showed up twice. And we'll write the x minus 13 over x plus 3. All right, I'm running out of room for my constraints, so I'm just going to put little arrows there to tell you that they should go there. This -1 equation showed up from -infinity all the way to 5, right? That's where it stopped. Okay, so you can choose any x value you want to plug in that's less than 5, but you can't plug in -3, because wouldn't that make our denominator 0? Okay, so you can let the x values be anything you want, less than or equal to 5, but this is kind of a double constraint. So this is your values you can choose, but we also have to, I'm again running out of room. We'll have x is less than or equal to 5, but you also have to show that x cannot be -3. Are we okay with that? It shows up twice from -infinity to 5, but notice how we excluded -3. All right, this last equation showed up from 5 to infinity, so we can say x is greater than or equal to 5. All right, so that one was a little tricky because it was a fraction, but are we okay with including that excluded value, that a number that doesn't work? Okay, we're actually going to make note of that down below. What must be taken into consideration that we didn't have to before? Okay, we had to, let's see, we'll say we have to include any value that makes the denominator equal to 0 on the number line. Okay, so your homework for this section is fairly short. It's only 3 of these examples. One of them is kind of the addition ones like we did yesterday and today, but 2 of them are actually the fraction ones because those are a little bit more involved. I want to make sure you have extra practice on those. So in the 10 minutes or so that we have left, you could probably start some of those problems. Is that all right? All right.